Hello again. This is the solution video for this packet, but just for questions 4, 5, and 6, 7. So let's do it. The question 4 starts out with a fabulous name, Amy. Amy is graduating in the spring from Howard with a degree in accounting. They offered her a salary job of $48,000. How many standard deviations above or below the mean is her starting salary if the mean and standard deviation are 47,500 and the standard deviation respectively is 1470. So right off the bat, I'm gonna copy those numbers down with my symbols. They gave me the average score X bar, so I'm gonna put 47,500. They gave me S sub X, the standard deviation, which is 1470. I can make a normal curve, but they didn't really say anything about the normal curve, but I'm gonna go ahead and use my Z-score formula. Once again, Z-score is equal to AP statistics. Actual minus predicted over the standard deviation. So when I look at this, I say to myself, the actual value she got was 48,000. We should have predicted her to get the average, which is 47.5. 47.5. All over the standard deviation, 1470. So this feels like an Algebra 2 question. They gave me every piece of my formula. So I can calculate the Z-score just by doing the math. When I subtract the two numbers in the numerator, I get $500. So it appears as if she got $500 more than I expected her to get. So I'm definitely thinking she got above, but they're not really asking for direction. They said, what's the distance above and below the mean? So I take 500, which is 48,000 minus 47,500, divided by 1470, and I get an answer of 0.34, and I notice that that's one of my solutions. Let's see. Question number 5. Question number 5, they gave me a picture. So here's some important things I'm noticing. It's saying, which of the following things about these two box plots must be true? So I'm looking for the true one. I'm kind of ignoring the false ones. So as I look at this, I notice that really a box plot is just a 5-number summary. So I'm going to go ahead and label my graphs that. So I got my min, quarter 1, my median, quarter 3, and my max. I'll show you that in a minute. And I'm going to label it on the second one. Min, quarter 1, median, quarter 3, and then my max. And ultimately, it looks like in this question, they're going to ask me to either compare the min and the max, which in a way is what they're asking, because they're asking me to compare the range, which is, let's go ahead and write that formula. So the range is max minus min. So the age range in the classroom goes from my age, 40, down to the youngest person in class, which is 16. So the age range is 40 minus 16. So it's pretty easy to remember the range formula. And then IQR. They're asking us to compare IQR, which is the width of the box. And then as a formula, it would just look like this. Quarter 3 minus quarter 1. So that's why a box plot is useful, because it shows us visually the width of how wide that center spread is. So this is the range, and this is the range of the center 50% of the data. So reading this, it says IQR of data set A is smaller than IQR of data set B. So let's zoom in. It does look like when I go quarter 1 minus quarter 3, or excuse me, quarter 3 minus quarter 1, the width of this box is smaller than that one. So I've found my answer right off the bat. That's true. Now you can keep moving forward, but you guessed it, all of these other ones are false. So I could rewrite it just to kind of learn. It said the lower quarter is greater than the upper one. No. The lower quarter happens to be, the lower quarter here, quarter 1, happens to be less than quarter 3 on the other data. So B is false. The range of A and B are equal. That's very obviously not true. Whisker to whisker, A has a much bigger range. D, the median of B is greater than A. The median of B, no. The median of B is way over to the left. So the median of A is much greater. That's the middle of the box. Last one, there are more data in each set. So that's the one fallback of a box plot. I'm going to write that down. In a box plot, I can't tell how much data. That's also the benefit of a box plot. So if I'm comparing two sets of samples, and this one's talking about 50,000 people, and this is talking about 500 people, I can compare the data using the box plot. And the box plot doesn't really tell me how much data is in there. What does tell me is a stem and leaf plot. So you have to be careful comparing stem and leaf plots when you have different amounts of data. Okay, let's scoot to question 6. Using a histogram, this one reminds me of an Algebra 1 question. Using a histogram, figure out what is the number that's the average. So it looks like we talked to 25 students. Let's make certain of that. So I like to put in a histogram the number I collected. So I'm going to go ahead and do that. It looks like, and I'm just going to confirm I talked to, in fact, 25 students. So let's do that. I'm going to put 10 plus 8 plus 4 plus 3. And I agree, that's 25 students. So it looks like we asked 10 students and they said, nope, no pets. We asked 8 students, yep, 1 pet. 4 more said 2 pets. 3 said 3 pets. So let's go ahead and add up all the pets that the whole class had. So 10 said no pets, so that's still no pets. 8 said 1 pet, so that's 8 total pets. 4 people said 2 pets, so that's 8 more pets. And then 3 people said 3 pets, so that's a total of 9 pets. So now the work on my paper looks like this. I'm tallying up all the pets in class, and it looks like I have a total of 25 pets total. So out of 25 students, everybody collectively had a total of 25 pets. So when I divide 25 by 25, it looks like on average, we had 1 pet per person, even though we didn't have 1 pet per person. But on average, we do. Last question. This is a design question. So I'm going to write the word design here on the side. And this is where we started this year in Chapter 4. So let's read the question. To determine how students at a particular college feel about cigarettes, all students were chosen to have their emails published in the college directory were sent an email with a link. What's wrong with the method? So right off the bat, I'm saying to myself, well, wait a minute. It specifically said only the students that chose to have their email put in there. So did each student really in the university have an equal chance of being chosen? Ultimately, that answer is no. They didn't, because if they didn't provide an email address, they were not part of the survey at all. So it wouldn't make sense to make an inference about the whole population of students. All you'd be able to do in this example is make an inference about people that gave their email addresses. So as I'm glancing through here, I'm noticing that E addresses what I just talked about. So I had a sneaky suspicion that was what was wrong. So I'm going to circle that. Not all students would have had an email listed. So ultimately, that's what's wrong with the way they designed the study. Once again, you've just reviewed the video on questions 4 through 7.